Okay, let's solve this LeetCode problem. We're given a binary matrix, and we can choose any number of columns in the matrix and flip every cell in that column. Flipping means making 0, 1 and making 1, 0. So what we want to do is to find the maximum number of rows that have all the values equal after some number of flips. You will do, given this matrix, you will do some flips over the columns, and after that, some rows will have all the values same. Either will be all of them 0 or all of them 1. We want the number of such columns, and we want the maximum such columns, right? Okay, now let's look at the first example, although not much helpful, but just to get the gist of the problem. We have 0, 1 and 1, 0. If we choose to flip any of these two rows, it doesn't really matter because it will not make a difference. If we flip this row, we'll make 1, 1, 0 and 1. Now we have this row all the values same, and if we flip this row here, then we'll have 0, 0, 1 and 0, and again the first row have the same values, and we have only one row. Or we choose not to flip any rows. In this case, we have this row here, which is what we want, and in this case the answer is just 1. And in the second test case, we have 0, 1 and 1, 0. So if we flip this row here, we'll get 1, 1 and 0, 1. Sorry, 0 and 0. The first row, all values are same. The second row, all values are same. So the answer is 2 in this case. If we choose to flip this row here, then we would get like 0, 0 and 1, 1. Then again, we have all values same here and all values same here. The answer is 2 in this case. But what I want you to consider to solve this problem is to think about abstractly. Now, imagine that this is your matrix, right? Somewhere in the middle, we do not care about the dimensions of the matrix. You have, let's say, 0, 1, 0, 1, right? So what happens here is that you might think that's what I thought. Okay, I will make either this row all zeros in my optimal case, in which I flip some columns, I choose some columns and flip them, and after that, either this column changes all to ones, so basically either this column becomes 0, 0, 0, 0, or 1, 1, 1, 1, or it's some like nonsense. It's like 0, 1, 1, 0, maybe something like that. If this might not be in my optimal case. I mean, if I found at the end that I have 5 rows that are equal, that have all the values same, either this row is one of those. It's either zeros or ones. In this case, it's one of these 5 values, or it's something different, and it does not affect this count here. Now I suppose that, okay, let us say this row here, I will make it all zeros or all ones. For example, in order to make it all zeros, I need to flip. What do we have to do here if we want to make this all zeros? We have to flip this row and this row. So basically we have to choose this entire row and choose this entire column, there's 2 columns, and we want to flip it. Now what happens that we will make this 0 and this 0, or we can make it all ones. It doesn't really matter, you'll see. So we have 0, 0, 0 and 0 now. Now in the array, in your matrix, there might be other values that are equal to this row. What you did to this column will make the same to this rows as well, because they're the same. If we'd had this one here, then we would make this all zeros or all ones, whatever we do to this column here, this row here. Or we might have this case. Okay, this is the first case where we have another row that is the same as the current row that we're considering, this one here. Or we might have a row where we have ones, the opposite values. Basically, the corresponding values are opposite. We have 0 here, we have 1 here, we have 0 here, we have 1 here, and we have 0 here, 1 here, and 1 here, 0 here, right? We have 1, 0, 1, 0. In this case, when we flip this row, like right here, if we make all of this one, so basically this is the opposite or the inverse of this row. If we make all of this into zeros, if we flip this all into zeros, then we flip the inverse, the opposite of, into ones. Let me show you. If we have 0, 1, 0, 1, and we choose this 2 column, and we say, okay, we're going to flip everything on this column, and we're going to flip everything on this column, we make this 0, 0, 0, and 0, right? Then there's 2 affected. And we also have the opposite of it. So now, look what happens to opposite of it. We have here stands 0, here stands 1. Then we flip, when we flip this column here, we'll make it 1, 1, 1, and 1. So it's all the same. We want this. So when we had 2 cases. When we have a column, we consider, okay, this column might be, if I want to have this all the same, I can make all of this values on this row, this one here, all zeros or all ones. If I want to make this one all zeros, I need to flip these 2 columns, right? Then what happens, I'm actually doing the same thing to all rows that are the same as this row, or the opposite of this row. The rows that are same as this row, they will be all zeros if we're making it all zeros. And the rows that are the opposite of this row here, like this one, this rows will be the, if we're making it zeros, those rows will be ones. If we're making this current row all ones, the opposite rows will all zeros. So in this case, we only consider 2 cases. For a current row, let me actually clear this and draw it again. Okay, if we're making this, if we're choosing to make this row same, all values same, we're going to make it either zeros or ones. So this is going to be 1. Then we do the same to all rows that are the same as this row here. If we have a row somewhere in the matrix, we're going to make 0, 1, 0, 1. This is the same as this row here. We will also make it all zeros or all ones. If we make this one all 0, this will be all zeros. And we also have an impact on the rows that are the opposite of this one. If we have somewhere in the matrix, if we have 1, 0, 1, 0, basically this is the opposite of it. So if we make this current column, the current row that we're considering, if we want to make this all zeros, we choose basically these 2 columns, right? We're going to flip. We're going to do flips on this column and on this column. Then when we flip this 2 here, it will all be ones. So when we make this all 0, the opposite becomes all ones. And if we make this all ones, if we go back, then we have to choose this column, and we're making this one all ones. Then we have to choose this 2 column. Then we flip this 2 and this 2. We're making this one all ones, and this becomes all zeros. So there are 2 cases that are affected. There are rows that are equal to this row, that are basically the same as this row, or the opposite of this row. So we do the same thing for every row. We can check the same thing. We can say, okay, let me make this row all zeros or all ones. It doesn't really matter. There's 2 cases is symmetrics. What you have to count is that if I'm deciding to make it all equal values, if I'm deciding to make this row have equal values, then I will only affect the rows that are same as this row, or the reverse, or basically the opposite of this row. So I have to count those such rows, right? So we do this for every row. We can do this for another row, maybe here. So we might have a row here, and we say, okay, let's now decide that we're making this row all the values same. So basically you try to do it for every row. You say, okay, in the right, in the at the end in my count, I'm actually counting this row, so because all the values are same. So, or I'm counting this row, I'm counting this row. We try to make every row have same values, and for this we have to flip some columns. And when we do that, we're affecting, as we said, the rows that are same as this row or the inverse of this row. So what we do, in short, we count the number of inverse, the opposite rows, and the same rows as the current row. And we do this for every row, and this is going, the maximum of this count will be our result. Now let me show you the code. Okay, here's the code. Then first, before I explain this part, let me explain this part. This basically counts the rows that are same as this row or the opposite of this row. We go over every row of the matrix. We're given a row. We have to count the number. Basically, this count row says the number of rows that are equal to or the opposite of a given row. We're given this row, and we have to count such rows in the given matrix. So we go over every column. Then we first check if the first value of the current row that we're considering and the row that we're at currently in the matrix, if they're same, then we only have to check for the equality of these two rows. Then we have I always keep this boolean flag here. I have okay. That basically means that okay, we found a row that is either the same as this row or the opposite of this row. So in case of same, so basically we said the first if the first values of the current row and the row that we're given, if they're same, then we're checking the equality case. Then we check if these two rows are equal. So at some point we're going through every value of this two row. At some point, if they're different, we're just going to set okay to false, meaning that okay, this is not the same. And if this was not same, if we're not checking for the equality case, then we're checking for the opposite case. In opposite case, the rows have 0 and 1, or 1 and 0. So basically you can do that by adding those. If their sum is 1 and is not 1, if they're opposite, it's 0 1 and 1 0, and their sum is 1. If the sum is not 1, then they are not opposite. So we set okay to false and just break out. At the end, if we could find some row that is the same as this row or the opposite, then we increase the number of count. And then we go back here. That by the way, this has a time complexity of mn or of mn. And then we have another loop here. It's O of m. Basically, we'll end up having O m squared times n, which was fine for this problem. And then we go over every row of the matrix. We say, okay, let's count the number of rows that are equal to or the opposite of this row. So basically we pass in the matrix and the current row, and we take the result, the maximum result. At the end, we return this. So that is all for this problem. I hope you liked it. It's helpful to you. And I don't know if you want to give a feedback, just write it down in the comments. See you in the next videos.